So up until now we've been looking at examples where our line of best fit is an actual line. We're going to now look at ones where they're either a parabola or a cubic wave. So that's either going to be a quadratic or a cubic regression. Okay, and so those are number 5 and number 6 on our calculator. So let's take a look at the first example and figure out what we're going to do here. Okay, so it says if 400 children attend an afternoon movie, the price of admission is 80 cents per ticket. So that's this example here. If we charge 80 cents a ticket, 400 people come, we make $320. Here are some values if I change something. And the question here says for every 10 cents I add to the ticket price. So this is kind of what I can control. I can't control how many people come, but I can change the price of the ticket. So you can see in this case that I'm adding 10 cents per ticket. And what happens is, it changes. Less people attend, but I may make more. Okay, what we're supposed to do is plot the data on a scatter plot, and it tells us here, put price of ticket into L1. So I'm going to put this L1 and income in L2. Now the question is, why didn't I choose one of these to be L1 or L2? Well, I can't control that. So what I'm thinking about is, if I change ticket price, how will that affect my profit margin? Okay, so that's why we're going to use L1 and L2. Okay, so let's put that in the calculator. So we'll go back here. I've got all kinds of stuff to clear. I want to clear this. I'm going to go to here, and I'm going to clear my list. L1, L2, this is all from the last example. Okay, so let's plot this into our scatter plot. So I want 80, 90, 100, and 110. And then here, I'm going to put 400, 3, oh, no, that's not what I want in there. Let's go back. I wanted 320. Okay, and then 324, and then 320 again, and then 308. Okay, so just to remember all my steps here, if I go zoom 9, that will give me a scatter plot. Now if you look at that, you can see that that looks like a parabolic shape, right? I'm going to just quickly draw that here. I've got something like this. So you could see that this is probably this sort of a shape. Okay, so let's figure out what our equation is. If you remember, we go to Calc, and since I think it's a quadratic, I'm going to press 5 this time, and I want to go, sorry, wrong button. Let me clear that off. Okay, I want to go L1, L2. And so, a little different, the equation. So it says y equals ax squared plus bx plus c, and it gives me what a, b, and c are. So I'm going to have y equals negative 0.04x squared. All right, plus 7.2x. And then it says plus 0 for c. Okay, so this is my equation of my quadratic that represents this line of best fit. It says how many increases of 10 cents should the cinema add to the price in order to maximize the profit? Well, in this case, if I look, it looks pretty obvious to me what the highest point is. I think that's actually my data point. Okay, but the best way to do this now is to actually put the line of best fit in, the regression equation, and then find our maximum. So I'm going to go here. If you remember all these steps, vars 5, equation, enter, that puts my equation in there, and now I have the actual line of best fit. So now I'm going to go to second trace, and I want to find the maximum. So let's put the left and right bounds. Yeah, it looks pretty obvious that that's going to be my point. So I'll go enter, and then I'll go to the other side of that highest point, enter, enter. And what does it tell me? It tells me when x is 90, I get 324. Okay, so I'm just going to write that when x equals 90, y is 324. What does this tell us? Well, originally we started with 80 cents, so it looks like one increase of 10 cents will give the maximum profit of $324. Okay, so let's try another example like that. This time it's not going to tell us, oh, it does tell us what to put L1 and L2. Let's see if we can figure it out. Don't look at part A there. A telephone company can get 800 subscribers at a monthly rate of 25. It will get 60 more subscribers for a $1 decrease in the rate. So you can tell again that this is what we're controlling. Okay, and then we want to find out when we're going to get the best income, the highest income. Okay, so L1 is monthly rate and L2 is income. Okay, so pause it right here, and you guys can figure this out. Put it in the calculator and see if you can answer these questions. So plugging the information in, I get this equation, and this is the equation of the quadratic. And when I look at my graph, it looks something like this. And you know, actually, the graph cuts it off like this, and you kind of say, where is the maximum? I can't really see it. Here's the picture, right? So this is what it says, and I want to find the maximum. It looks like it's to the left of my screen. Well, don't forget, the reason it looks like this is because we've cut off the values for x. If you remember, our x values are only 22, 23, 24, 25. So if you think about that, you've got 22, 23, 24, 25, something like that. Okay? It looks like our maximum might be here somewhere. So what do? Well, when we graph zoom 9, this is the picture it gives us. Maybe we should zoom out and get a bigger picture. So I'm going to press zoom out, number 3, and then press enter. And now you can see that's a much better picture of what the parabola actually is. And this will allow me to now go to second trace, and I want to find the maximum. Okay, and I can scroll here along until I think I've passed the highest point, and I can watch the y values. Yeah, there it goes down. And now I'll scroll over to the other side, and I can see now the y values are going down. So the max is going to be somewhere in there. And it tells me the maximum is when x is 19.166. Okay, so let me write that. So x is 19.166, and y will be 22,041.667. Okay, what rate will yield the maximum gross monthly income? Well, do I have the option of charging $19.16 or 17 cents? I suppose I do. Okay, so I'm going to say, therefore, the monthly rate should be $19.17, so that the income will be maximized to $22,041.67. Okay, now a lot of times you can't be that precise. You know, we might want to just say we're going to charge $19. But in this case, we have a pretty clear picture of what it should be. Okay. Third example we're going to go to. This one, there's a much bigger table here. If you look at the table, we're from, like, this is going to be L1. Here's L1 continued. Okay. And then this is L2, and this is L2 continued. Okay, instead of being one long table, we've kind of split it up like that. Okay, so it says the year after 1979, so we're starting at 1979, and what is the price of gas? This is crazy, you guys. Look at this. In 1979, gas was 22 cents a liter. And so 29 years later, so when's that going to be? That's going to be 2008. Gas was $1.15. And right now it's about $1 a liter, so it's gone down a little bit. But I remember, I mean, when I was in high school, this is the price of gas. It's a lot cheaper to put gas in your tank. Okay. So use technology to graph the data as a scatter plot. So what I would like you to do is plot that in the scatter plot, and then we'll come back, because it's going to take you a little while to do it. So I put all the data into the scatter plot, and then went zoom 9, and this is what you get. You can see that does not look like a straight line. It does not look like a parabola. This is going to be a cubic regression. Okay, so that means we're going to find the equation, going to stat, calc, and we're going to go cubic regression number 6. Okay, and so L1, comma L2. So it looks a little bit more complicated, but let's see if we can write that down. So first of all, this is a cubic function. Okay, and my equation is going to form, it's going to go this form, ax cubed plus bx squared plus cx plus d. Okay, so I get y equals 0.12 x cubed. I'm just going to go to 2 decimals when I write it down. When I put it into the equation, it will take all of these decimals. Okay, and then it's minus 0.46 x squared, and then plus 6.30x plus d is 23.45. Okay, so that's my cubic regression. Use the equation to estimate the average price of gas in 84.85. Okay, so to do this, first of all, let's put it into here. So I'm going to go let's go back. We're going to go vars 5. So that puts that mess into there. Now let's see what it looks like on a graph. Pretty nice equation. Okay, and we're supposed to figure out what? We're supposed to figure out what the gas would be in 84.85. Okay, well, to do that we need to figure out where 84.85 is. Okay, so this is 1979. So then this would be 80, 81, 82, 83. This is going to be 7 years, so this is going to be 86. So in there is what we're looking for. The price of gas in 1984, 1985. Okay, so to do that, what I'm going to look for is when x is 5 and when x is 6. Okay, because L1 is our x This is going to be our X values. Okay, just take a look. If we go to our table, the first column is our X values, and so we have right between 4 and 7 there, we have the 5 and the 6. So let's go to our graph, and we'll go second trace, and I want to figure out the value when X is 5. So it tells us gas was $44.84 cents. Okay, so gas 44.84 cents. Now if you look at our information here, maybe that doesn't quite make sense, because according to this space here, it should be somewhere in the 45 cents. Okay, so remember that this is our line of best fit. It's going to approximate stuff, and you can see that if you zoom in a little bit, this is not going to be a perfect fit with that line. You can see how that line doesn't quite match up perfectly in places. Okay, so we're estimating, you can see where the cursor is there, we're estimating somewhere in between those two dots, and it happens to be the line is below those dots. Okay, but we've proven and we've shown why this is the answer. So this is a good answer. Okay, remember we are estimating. It might be a little bit off, but based on our data, that's what it is. Okay, now you can also find it for x equals 6, but it should be pretty close to that. Let's go to part C. Estimate the year in which the average price of gas was 56 cents. Okay, so we want to know when the gas is 56 cents. If we just want to trace, we could try that a little bit. Okay, so we're going to go here, and so you can see it's 57 cents there, then it's all of a sudden it's 54. But remember, that's going on our actual data plots. So let's instead use a different arrow. So now I've put that cursor on the line. Okay, so now I want to know when this is going to 56. Okay, just to be clear again, what did I do there? When you first press trace, and you use those arrows, you're moving from dot to dot, from scatter plot to scatter plot point. The second I press the arrows up or down, it puts the cursor on the line. Now it's not going to follow the dots, and now when I move it, it's following the line of best fit. Okay, and so I want to move it until I get to approximately 56 cents. Okay, it's not going to let me do anything, so let me go zoom 9. So now I'm zoomed out. I'm going to repeat those steps. So I'm going to press trace, and then I'm going to get off those dots, and now I'm moving along the line. And you can see right about there, somewhere I go from 55 to 56, somewhere here at when x is 16.5 approximately. Okay, so I'm going to write approximately 16.5 on x-axis, and again we need to go and see where is that. Okay, where is 16.5? What year is that? Well, this was 79, we got 86 here, this is 87, 88, and then 89, 90, this is 91, and then 92, 93, this is 93. Alright, and that's 14. Then 15 would be in 94. 16 would be in the year 95. So we're saying it's about 16.5. So we're going to say in approximately 1995. 1996. It's somewhere between those two dates. Okay. So I'm going to stop there. I'm going to give you some homework. and then we'll do the box problem in the next video. Okay,